equations of parallel and perpendicular lines. So if you think about it, let's do this for a second. Let's draw a graph. And let's say we draw y is equal to 1/2 x minus 4. Okay? We're going to graph that. So let's... Okay, so we all know that the first thing, this is slope-intercept, right? That's my slope, that's my y-intercept. You guys remember all this?
Yeah.
And so my y-intercept is -4, so I go down 1, 2, 3, 4, and then I rise 1 and run 2, right? So from here I rise 1 and I run 2, so I put a dot. I rise 1 and I run 2 and I put a dot. And I can draw this lovely straight line. Hang on a second. Not bad.
Yeah.
Okay? Now, let's say I wanted to draw another line that's parallel to that. What do you think? What do you think would be the same as in this equation?
The rise over run.
Why?
Because it's the starting point that matters.
Right. So we started at -4, right? But the slope, remember slope is, in order to be parallel, your slopes have to be identical, right? I mean, if you have a slope, those are not parallel, right? But if you have a slope here and you have a slope here, they're parallel, right? They're just starting from a different place on the y-axis. So if you wanted to write, we could let's just write another equation with the same slope and a different y-intercept. Y-intercept, okay? So let's do y is equal to 1/2 x plus 3, okay? So now we've got 1, 2, 3. We're going to put a dot here, but we're still going to rise 1 and we're going to run 2. Does that make sense? We're going to rise 1, run 2, put a dot. Rise 1, run 2, put a dot. And we're going to draw our line. Hopefully I'm doing this fairly well.
Parallel.
Right? They're fairly parallel, right? That's pretty awesome. So with it, given that, all right? Let's see how far can I go on this thing. Okay, there. Is that right? Okay, and oops, jeez. I think this camera is closer than it normally is. When they put the rug back in, I always do it based on the rug, but I think the rug is further forward than it used to be.
I think we might have moved in moving images.
We did. All right. So I don't know what it's. If it's out of focus, let me know, okay? Because I have to move it now. But anyways, all right. So if I gave you this, y is equal to 2/7x plus 25. Give me an equation that is parallel to that.
Y is equal to 2/7x plus 24.
Yes. All right. Yes, Jan.
Y is equal to 4/14 x plus 23.
Yes. Okay, Basie.
Y is equal to 2/7 minus 25.
Yes. Somebody else?
Oh.
Yes.
Y is equal to 8/28 x minus 24.
Yes, right. Yes.
Y equals 2/7x minus 1.
Yes. And what about this?
Wait.
Turtle.
That's what I was gonna say.
Jeff.
All right, say it. Right? Those are all parallel. We know it. Why do we know? Because the slope is identical. Even though some people were a little fancy and they decided to say instead of 2/7, they said an equivalent fraction, right? 2 times 2 is 4, 7 times 2 is 14, right? 2 times 4 is 8, 7 times 4 is 28. So they're the same fraction, they're
If you
equivalent
just-
fractions,
If you
right?
just reduce it, it all goes back to the
Exactly, exactly, yes.
Can I get my water bottle?
Yes, you may. But notice, so that's interesting. That's interesting. If a slope could also be, in this case, we have a slope of 1/2. We could have done a slope of 2/4, right? Do you agree with me? Guys?
Yeah.
Do you agree with me? It could be. So let's just see if that works. Rise 2, 1, 2, run 1, 2, 3, 4. It works, right? So it works no matter whether the fraction is reduced or not. It's just that it's much easier to graph when it's reduced, right? I would rather graph 1/2 than 50 100ths, right? I would not want to go up 50 and then over 100, right? It'd be much easier to do 1/2, okay? So, okay, beautiful. Now we got to talk about perpendicular.
What?
Now,
Yeah.
I have mentioned a few times over the year this word, correlation. Correlation. Does this graph, this line right here, is that a representative of a positive or a negative correlation?
Positive.
Positive. So correlation really is like slope. So if the slope is positive, the correlation is positive. It's going up to the right. If the slope is negative, it's going to go down to the right. Now, if a slope, sorry, Basie, but you got to listen. But if this line is going up to the right, what is a perpendicular line and what direction will it be going? First of all, what is a perpendicular line? Perpendicular to that, how would I do it? It would be like this. And perpendicular means what?
Crossing at a 90-degree angle.
Yeah, this angle has to be 90 degrees, right? Has to be 90 degrees. So if this has a positive correlation, if the first equation has a positive slope, a positive correlation, do you agree with me that the second equation, if it's going to be perpendicular, has to be a negative correlation, negative slope? Does that make sense?
Yes.
It's got to be. It's got to be. Does it make sense? All right. So now, I'm going to just tell you. I'm going to tell you the formula for perpendicular lines. Let me see. Let me write it up. Let me do it right here. So, in order to create a perpendicular line, is this on the video? Yes, okay. In order to create a perpendicular line, you take the original slope, right? And, take original slope and convert to its negative reciprocal.
Oh, okay.
All right. So negative, you can either use the word negative or I could use the word opposite. Okay? Because sometimes when I say negative, people get confused. But if the slope is 1/2, then the slope of a line that's perpendicular to a line with this slope would be negative 2/1. Does that make sense? I have to flip it, and I have to change the sign. Does that make sense? If the original slope was negative 2/3, then that means the original slope is a negative correlation, so it's got to be positive 3/2. Positive 3/2. Does that make sense? You guys see that? All right?
Yeah.
So here we go. We've got y is equal to 4/5 x minus 1. Give me an equation, any equation, of a line that is perpendicular. Mushy.
What? Oh, a perpendicular? Uh, wait, y equals negative 5/4
No.
x, what? Yeah. Minus 1.
Yes. All right, another one.
147 plus 62.
Another one.
No.
Give me one more that's parallel, but that's perpendicular to this. All right.
Oh, you can do more than one
Tess.
now.
Another line that's that's perpendicular to this. Guys. So, are you taking notes? Are those notes or are those? I need you to take notes. Okay. So, somebody else. James. Another equation that is perpendicular.
Negative 10 over 8. Would that work?
Okay,
Minus one.
that's fine. So y is equal to negative 10 over 8. X.
Minus 1.
Well, that would be identical to this.
Oh, so.
So how
Plus
about minus?
one? Oh, minus 1.
Or plus 1?
Oh.
Sure, that's fine.
Sure. Yeah.
Right? You see
Or
that?
minus 2.
So if I'm asking for 5 different, let's say I was on the homework, I'm going to give you a line, an equation. I'm going to ask you to list 5 lines that are, equations of lines that are parallel. Okay? Parallel means they're not the exact same line. They've got to be away from the line, right? So what changes in order to make different parallel lines? The y-intercept. This negative 1 can be positive 1, or negative 20, or positive 15, those kind of things. Does that make sense? Okay, now, are you guys ready? Does that fist to 5? I just want to be sure people understand.
27.
Okay,
It's pretty simple.
it's pretty simple. All right. All right. Okay, so what if I did this? I said circle 3 equations. I might have to hit that, I'm sorry.
We're fine.
5, 6, 7.
Hello?
I didn't think it's part of
I don't know that number right now. Okay, here we go. Circle 3 equations. So guys, you're starting to talk. Circle 3 equations that are the 3 equations that are parallel. So, so here we go. Y is equal to 4x plus 1. Y is equal to 27 plus 4x. Y is equal to negative 4x plus 10. Negative 8x plus 2y is equal to 14. And let's see here. 3y is equal to 12x plus 4. Okay, I want to know, well, at least circle, instead of saying 3, because I don't know how many I did, circle all equations that are parallel. All right, so which, all, sorry, that's all. All equations that are parallel. So, yeah. So which ones do people notice? I'm going to wait until I see more hands up. I just want to see how many people notice parallel lines. What are we looking for? We're looking for a slope.
Opposite.
Do we know a slope?
Parallel.
Do we know the slope easily if it's in y equals mx plus b? Yes? Do we know the slope easily if it's in y equals b plus mx?
Yes.
That's the same thing, right? Y. So we know the slope if it's in y is equal to mx plus b. The slope is the m, right? We know the slope if it's in y equals b plus mx. Do you agree with me? I just flipped these, right?
Yeah.
I still know the slope is the number in front of the x, right?
Isn't
But
that a
do I know the slope in front? I mean, do I know the slope when it's a standard form?
problem? Yes, you do.
When it's
Because it's 4 over 1.
2x plus 4y is equal to 10, do I know the slope?
Yeah.
Easily?
Yes.
How do I know it?
4 over 1.
What?
Just 4 over 1. Oh, wait.
Well, no.
Oh,
No.
no.
Think
I
about
thought
it.
was
What is
y
this?
equals
The only way you're going to know the slope is if you graph it or if you convert it to y equals, the y-intercept form. Because y-intercept form has the slope in the equation. The standard form does not have the slope in the equation. So you kind of have to convert it, right? I'd have to subtract 2x from both sides.
Yeah, you
So I'd have 4y is equal to negative 2x. This was homework last night,
Yeah.
right?
Yep.
And then I have to divide by 4, right?
Yeah.
And then I could see, oh, well, it's negative 1/2. My slope is negative 1/2 here. Does that make sense? You see what I did? Right? Dan, does it make sense? Jaden, does it make sense? You got it? Okay. When it's in y equals mx plus b, the slope is right there. It's in front of the x. But when it's in standard form, you don't have the slope showing. So you have to convert it to y equals mx plus b. And that's what the homework was last night. We had to move anything that's not a y over to the other side. I subtract 2x, so I got 4y is equal to negative 2x plus 10, right? And then I have to divide by 4 because I only want y equals, not 4y equals.
Yeah.
And then I can see, oh, yes. So now I've got y is equal to negative 1/2 x plus 10/4, right?
Yeah.
So I know my slope is negative 1/2. Okay.
Yeah.
All right. Are these two equations parallel?
No.
Irene, what do you think?
No.
Why?
Oh, wait, no, yeah. MX plus B or y equals B plus
Okay, awesome. So notice the slope here is 4. The slope here is 4. These two are parallel. Okay? Is this one parallel?
No.
Well, it's a negative for it.
No, it's not.
So,
No.
would that be
No,
parallel?
it's not.
No, not parallel.
Frick no.
Definitely no. That's a no. Is this parallel?
No.
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 How do you know?
Because I know. Me no.
No, because, no, you add it. No, it is, it is, it is, it is.
Check.
So,
There's
what do we have to
move
do?
8 and then it's positive 8 and you divide by 2 and then it's 4x and you can graph it, so it is parallel.
So we've got to, remember, we got to set it to y equals, right? That's the slope intercept form. So we're going to add 8x to both sides. Add 8x. And that gives me 2y is equal to 8x plus 14.
Yeah, and then
I've got to divide by 2. Oh, when I divide by 2, I get y is equal to 4x plus 7.
yeah.
Is that parallel to these two?
Yes.
Yes. So we know this is parallel. Now, is this parallel?
Yes, it is.
How do we know?
Because if you divide by 3, the 12 equals 4x, and I don't want to do 4 divided by 3, but whatever it is, it'll work.
Right. Exactly. So that 12 divided by 3 is 4, so that's 4x. Therefore, this is also parallel. Does that make sense? Do you guys understand?
Yep.
Okay.
You see? All right? Because remember, it's got to say y equals in order for you to know what the slope is. If it says 3y equals, you got to divide by that 3. It's got to say y equals, right?
I'm confused on why that one's not parallel, because it is y equals
Ow. Here.
Do you see that negative?
Yeah, but it's not.
Because negative would make it go like that.
Yeah, okay.
See what I'm saying? Okay. Okay, does that make sense?
Yes.
So, and then if I did the same thing with two equations that are perpendicular, right? Let's see, how about that? Let's just do that. Circle, I want to give you guys plenty of time here. Circle all equations that are, circle two equations that are
No.
perpendicular. Guys, you guys are really noisy. So guys, I've been getting more and more comments. Just so you know, I get comments from all over the world. I really honestly do. I've been working with this kid from,
Russia.
oh God, I can't remember.
Sweden.
Um,
America.
Canada.
England.
I can't remember what he said. But
Africa.
one of the comments he said is, "Oh my God, that class is so noisy. Focus, people, focus." And he's, I mean, serious. I mean, it's like people see this, and they in other countries, you're not allowed to talk. You know, in other countries, in classes, period. You know, you do, and you're nailed, right?
Mexico.
Right. So just be aware that I would appreciate it if you guys were a little more focused. Okay, so we got y is equal to 1. Let's see. Let's do. Well, no. That's fine. 1/2 x plus 4. Y is equal to negative 1/2 x minus 8. Y equals 2x plus 7, or y is equal to negative 2x minus 1. All right. Are there any that are perpendicular to each other? Yes, Basie.
The top two, I'm pretty sure.
All right. What is the rule? Let's be sure. In order to be perpendicular, we have to change the sign, and we have to flip the fraction. Did the slope? The slope would have to go like that. This is 1/2. This is 1/2. It's negative. It's positive. Do you hear something? All right, Sienna.
There's the middle two. It's the middle two.
These two?
Yeah.
Oh, those are parallel? I mean perpendicular?
Yeah, they're perpendicular.
Right. This is a positive 2, and this is a negative 2 over 1. I mean 1 over 2, right? This is positive 2 over 1, negative 1 over 2, right? We flipped it. All right. Is there anything else that is perpendicular? Are there any other equations that are perpendicular? Are there any? Yes.
Yeah, the top and the bottom, because
The top and the bottom.
half,
I'll circle those
negative
two.
2 over 1.
Yes, those two are perpendicular, right? Okay, so that sounds good. So fist to 5. Do you guys feel like you have a good understanding of it? Okay, awesome. I'm going to stop the lecture and look.